Energy is another thing that chemists are interested in. We're very interested in matter, but matter and energy interact with each other, and so we need to understand a little bit about energy. There are two main divisions of energy: potential energy and kinetic energy. Potential energy, which is often abbreviated PE, it has nothing to do with running around the gym or anything. That is stored energy. It's energy as a result of position or composition. And this always reminds me of cartoons. I used to watch Bugs Bunny cartoons and Donald Duck and all those guys. And a lot of those cartoons, they seem to have a thing with hanging pianos out of second floor windows. And here'd this piano be hanging out. That piano has a huge amount of potential energy, because what's going to happen if that rope breaks? The piano's going to fall. It was always a grand piano. Those things are heavy. Have you ever helped lift one of those? Those things are really heavy. It's high off the ground, and it's really heavy. And if the rope breaks, it falls, just like that marker. I do that every semester, and every semester, same thing happens, falls down. It has potential energy when it's lifted above the surface of the earth. The farther up it is, the more potential energy it has. It's energy of position. We can also have energy of composition, and that's energy that is stored in chemical bonds. TNT, dynamite, has a lot of stored energy in it, doesn't it? You light it and it goes kaboom and blows things up. That's potential energy. The other type of energy is kinetic energy, the energy of motion. And energy can be converted between these two types of energy. When I drop the marker, at the top when I'm holding it, it has the most potential energy, and as it falls, it goes faster and faster. It's also getting closer to the ground. The closer it is to the ground, the less potential energy it has, but it's moving faster, and so it has more kinetic energy. The potential energy is being converted into kinetic energy. You think of a boulder at the top of a hill. It's got a lot of potential energy. You give it a good shove to get it started, and as it rolls down the hill, that potential energy is converted into kinetic energy. Here's an example of a cannon, launching a cannonball. So at the top of its trajectory, I was looking for a simpler word, path perhaps, at the top of its flight path, its potential energy is at a maximum because it's the highest off the ground. Its kinetic energy here is at a minimum because it was going up and it's slowing down and now it's starting to fall again. And as it falls, the kinetic energy increases, the potential energy decreases. So energy can be converted from one form to another, and it just happens. Nobody has to think about it. Well, kinetic energy is related to the temperature and the physical state of matter. All substances have kinetic energy. If we look at this marker right now, it's sitting on the table, right? Is it moving? Doesn't look like it's moving to me. How can it have kinetic energy? It's not traveling through space, but what are the particles doing? It's a solid, but they're moving, right? Just like you guys are the solid state of students right now, but you're still moving, right? And the particles in there are wiggling and vibrating and oscillating, and so it has kinetic energy, even though the object itself is not traveling. You know, that would be kind of frightening, wouldn't it, if it just started moving across the desk? I'm glad it's not doing that. So solids have the lowest kinetic energy, and gases have the greatest kinetic energy. Liquids are in the middle. Liquids, the particles are moving around, but in a gas, they're just zinging off, and they just keep going until they run into something, and they just keep moving around. So they have the most kinetic energy. And what happens is, when you increase the temperature of an object, you increase its kinetic energy. How do you get an ice cube to melt? You heat it up, right? You give it energy. And when you give the particles of the solid ice cube energy, they get more kinetic energy, and they're able to move more, and then they melt. So if we look at properties of the particles, kinetic energy, and movement, we see that a solid has very low kinetic energy, but it does have kinetic energy. The particles are not moving very much. They're not moving relative to each other, they're just wiggling around. They're fidgeting. Solids are fidgety. In a liquid, the kinetic energy is high, and the movement is greater, but it's restricted. If you think of a cup of water, or my cherished rock star here, which I was yawning during your exam, I'm sorry. That was a little boring for me. This is a liquid, right? The particles in here of water and my favorite caffeine and the other good stuff in there, they're moving around. We can't see them moving, but they're moving around. But they're restricted. They have to stay within the liquid. They can't go flying out through the top. So they're restricted. In a gas, the kinetic energy of the particles is very high, and their movement is unrestricted. They are free to just travel in a straight line until they run into something. Here's an illustration. This is an interesting picture because it shows water in all three physical states. We have snow, which is frozen water, and we have liquid water in this stream, and then we have this geyser shooting steam into the air. And the gas particles have a lot more kinetic energy than the liquid molecules, which have more kinetic energy than the solid molecules.